Okay, welcome to the next part in installment. This is the second set now. So I've done the first set, this will be the second set. So question one, differentiate the following. It's interesting that we've still got this being expressed as sine 3x, which implies that we would understand that we would do d dx sine 3x, as opposed to setting sine 3x to y and dealing with it that way. Okay, so there's a small thought about expressions and equations. Same thing, but nevertheless we'll show the difference. So for the chain we need to let u equal 3x and leave in its notation. Rewrite this in terms of u, leave in its notation. Then it becomes clear that we'll do this one time. Y dash is equal to dy dx, which is equal to dy dx. Do something else. On this occasion, hence. Yeah. So being able to do that step is the big part of what the chain rule is all about. You can do a shortcut. The shortcut basically says find the derivative of the two terms. So if y equals, so y dash would be equal to the derivative of sine 3x times the derivative of 3x. So we get differential sign is cos, so 3 cos 3x is a shortcut. Now I abhor shortcuts, and I honestly don't encourage you to do it. And as we go on today in these videos, it'll become apparent why that's really not good enough. Alright, so the calculus of this then is differential sign is cos, and so then the differential of 3x is 3, so we can put them as 3 cos u, or if you like 3 cos 3x, so that's our chain. Now, that means that you've fleshed it all out. Now, as you practice these chains, putting them together is helping you in another area that's yet to come. Problem solving words means that if you do the chain rule this way, you'll get used to dealing with the dy d somethings, d something dx's, and when you come to do word problems in the future, it'll be much easier. The end of the course is really about that, but I'll talk more about that in a little while. So for the expression type, it's the same thing. Now, once we've let u equal something, we can't then go and do d dx sine u, so we have to make it make sense. So it will be d du sine u equals. So that's the difference. Alright, so in the equation, we will have symbol equals equation. So y dash is equal to equation. Over here, we'll have symbol in term multiplied by the expression equal to. Now, it's just a subtle thing, okay, dot, dot, dot. It's just a subtle thing, but I want you to try and remember that there is a difference, okay? I put the equals there. I've not written d du equals, I've just said this equals. Alright, so we can do the calculus, cos u, and du dx is equal to 3. So they're the chains. Putting them together, d dx is in fact still d dx, just going through something else, even though it's a short form, and the something else is du on this occasion. So it's 3 cos 3x. It's the same result. So it's just a shorthand, okay? So whether you do it one way or the other, doesn't matter. All right, so that was A. So B. So d dx cos 7x, or assign it as y equals cos 7x, and let u equal 7x, u dx. Now proponents say let's do a shortcut. No, absolutely not. Okay, shortcuts are not welcome. They completely destroy your understanding of how to do this. Differential sine is cos, so the differential cos is minus sine. Putting the chains together, dy dx, minus 7 sine 7x. Now you can do it at your own failure of the subject and failure of maths 1. Let me be blunt. Okay, so this would mean to make sense. Cos u, and then equals. So du dx 7. This is going to be equal to. Oops, I didn't need to do that because I already had it there. Let's have it. Minus sine u. Putting the two together, we end up with the d dx of cos 7x is equal to minus 7 sine 7x. Okay, just a subtle thing, but really worth understanding. Okay, again, d dx and 4x, or sine tan 4x. Let u equal, in actual fact it's using both, so I'm going to start to switch this around a little bit just to be annoying, because the only thing that's common between the two is let u equal 4x, so the u dx is equal to, over here we're going to rewrite this as d du tan u. Over here we'll write y is equal to tan u. So dy du. So now I'm kind of doing the chain backwards. It's still there, dy dx. Okay, so this will be 4. And this will be sec squared u. So putting the chain together, y dash will be equal to 4 sec squared 4x, or sec squared u. Putting the chain together, we will get d dx tan 4x is equal to 4 sec squared 4x. Okay, same thing, just using the bits that are common. So it's probably useful, actually, I think I have an extension. Had the extension. So that's not relevant. So I'll just bring it all from over. We're going to check this tan 4x just as a matter of courtesy. So, and actually, there's two ways to do it. Differentiate. Actually, you know what? I'm going to just take the time to redo this this way, because this has a nice little feature to it. Okay. And the feature to it is that you can split the screen and do it like that. So if you want to do it side by side, differentiate y equals tan 4x. Let's see what that, or you can do it the expression way, d dx tan 4x. See if it makes any sense of that. So d dx, and look, we get the same result. So whether you use the expression or you use the equation, it doesn't matter. Okay, it doesn't matter. So we get 4x squared 4x in either case. Okay, so d dx and differentiate. So it's just a lovely way to deal with it. All right, so just keep working away. See if we can't get to our time. So for d, sine 9x plus 4. So we'll d dx that. Or we'll assign it as y equals sine to 9x plus 4. Okay, we will let u equal 9x plus 4 in both cases, and du dx becomes, this means we rewrite this in terms of y equals sine u, and so we get a dy u, so we're still doing dy dx, and this one now making sense will be d du sine u equals, so that's still d dx. Alright, so let's do the calculus of the u. So that's going to be 9. The differential of sine is cos. Okay, the differential of sine is cos, same calculus. Okay, so now we can put them together. The d dx of sine 9x plus 4 is equal to 9 times cos 9x plus 4. Okay, that's 1. Over here, y dash is going to be equal to 9 times cos 9x plus 4. So sine 9x plus 4. Okay, so it's worthwhile having a look at our video and seeing differentiate cos 9x plus 4. We can hit both of those, and cos 9x plus 4. So how do we end up? Satisfactorily? Cos 9x plus 4. So cos 9x plus 4 minus 9 sin x, same thing. Minus 9 sin 9x plus 4. Minus 9 sin x plus 4. And there it is. That's because I did cos, not sine. So be careful. That's hilarious. Does it change it? It'll only take the minus away. So that's alright. It'll change the sine to a cos. Okay, so 9 cos 9x plus 4, 9 cos 9x plus 4. That's now matched with what we put in. 9 sine, so 9 cos. Alright, so just you can check and verify as you wish. Okay? Alright, so what I'll do is I'll press pause there, and I'll be back soon to continue on with E.